Okay, let me share my screen and we'll work on the quiz. Okay, so here's the quiz. We are supposed to use the epsilon delta definition of the limit to prove that the limit as x approaches -2 of 3x plus 10 is equal to 4. All right, so as I mentioned a few days ago, how do you start these kind of proofs? What's the first thing you do before you even prove anything? Do you remember? Yeah, scratch work. So we're going to go backwards is the idea. So that's what we're going to do. And backwards, remember, says that f of x minus L needs to be less than epsilon. So if I write that, maybe I'll do it. I could do it. F of x is 3x plus 10, and L is 4. So let me go and pop it in here. So it's 3x plus 10 in absolute value. And then minus 4 needs to be less than epsilon. Any questions so far? Okay, well, we could simplify and notice we're hoping to get an x minus -2 in here. So that's our goal, is to get the x minus -2 in here, which is the same as x plus 2. So now what I'm going to do is I'll copy that, paste it here, and let's play with it. So we can say that 3x plus 10 minus 4. I'm hoping this is like brainless for you. 10 minus 4 is
6.
6. You better be able to do that. So we know that we can write 3x plus 6 is less than epsilon. We need x plus 2. So what do? Pretty simple.
Pull the 3
Take
out.
out the
Yeah, pull the 3 out, or how about just divide by 3? So we can say the absolute value of x plus 2 is less than epsilon over 3. Any questions so far?
No.
Okay, so now that we have that, we're ready to start our proof. So maybe I'll even write down scratch work. Okay, this is all scratch work. Now we're ready for the proof. So the idea here is we did all this work and we get to the absolute value of x plus 2 is less than epsilon over 3. And first thing, what does every single epsilon delta proof start with? What words?
The limit.
Not limit. Yeah, let epsilon be greater than 0. Let epsilon be greater than 0. So we're going to let epsilon be greater than 0. Then choose delta equal epsilon over 3. That was the scratch work. And it always takes a moment to type it out. Any questions on that so far? All right, now we're going to start out with the definition piece, and that is x minus c is less than delta. So x minus c is the same as x minus -2 is less than delta. So absolute value of x minus a -2 is less than delta. But delta, we chose to be epsilon over 3. Any questions so far?
No.
Okay, we can go x minus -2. Hopefully you can all do that. That's the same as x plus 2. So now we're basically going backwards. We're doing everything we had, but now we're going backwards. And what I can do, I copy and paste is the easiest. And then I can take that minus -2 and make it a plus 2. And I don't need the delta anymore because less than epsilon over 2. So that, and now, again, we're going backwards. We're there. So we're at x plus 2 is less than epsilon over 3. We can multiply by 3 now, undividing by 3, right? So let's copy, paste. So epsilon over 3 becomes epsilon. And then the x plus 2 becomes 3x plus 6. Any questions? Okay, and then there's the whole point of the scratch work. Now we can take the 6 and write it as a 10 minus 4. So hence, 3x plus 10 minus 4 is less than epsilon. Therefore, and now the point is the 3x minus 10 is the f of x. Minus 4 is less than epsilon. And that's what we want. So we can conclude that the limit is 4. And I can just copy the limit down. And that's it. That's the whole proof. Yeah, it's practice helps. You know, this is my guess. This is totally new to all of you. Even if you had calculus in high school, you probably may not have seen this because this is often not done in high school. But it is a college thing. It's done in pretty much all colleges do a little epsilon delta. Any questions at all on any questions? Okay, so if you're not able to copy and paste equations from within my text entry, so what I usually do is I just I click on it, I go Control C, and then go to where I want to paste, and I go Control V. So that's the way that's the copy and paste. It's a lot faster than trying to type it out wonky. I don't take off points for wonky as long as it's right, and you've communicated what you're doing correctly, then that's fine. But it's faster and prettier if you copy and paste. Yeah, if you have a Mac, I'm not as good at helping you, but PC should work. Any Windows-based computer should, that should work. So I'm not sure what's happening with your computer, but that should work. Any questions at all on this quiz? Okay, and then if you want, you can write QED. And then that's the full proof. Okay, let's talk about today now. Question?
Can I ask a quick question?
Mhm.
I was confused where it was saying like use the epsilon minus delta definition.
Oh, that's a dash, not a minus.
Oh, perfect. Thank you.
Yeah, that's kind of a standard way of saying epsilon delta. It's
Okay.
epsilon dash delta. So sorry, that wasn't supposed to confuse you. It wasn't a subtraction.
I still, I think, did it the right way. I was just confused why that was. Okay, perfect. Thank
Yeah, yeah, it's just epsilon dash delta is the way a lot of people write it. And that, kind of more people than not. So I figured I'd write it the way everyone else does. So sorry if it looked like a subtraction. That's Canvas, actually. You know,
you. No worries.
it is what it is. Yeah. Any other questions before we move on? Okay, so let's move on. And we took our quiz. So let me ask you, are there any questions about anything that's happened so far? So we've now fully, hopefully done limits and continuity, because that's where we are right now. And are there any questions about limits or continuity or anything else?
Number 9 on the homework gave me a little trouble.
Is it easy to read, or is it something that you have to share your desktop for?
Let me see if I can't pop over to it and read it.
Yeah, it's asking for, it's telling that it's a limit to equals infinity with a capital M equals like 1,000, and I just have no idea what that means.
Okay, so maybe you can read it to me.
Okay.
Because I don't
Yeah,
have these
okay.
memorized. And remember,
All right, so
your number 9 is, might be different than everyone else's number 9. There's randomization that happens.
okay. Well, so I don't want to jump on whoever just spoke then, but
Its limit.
for me, it's the limit as x approaches negative 2/3. It looks like 0.66666667.
Okay, I'll let it be 2/3.
Yep. And the f of x is 1 over 3x plus 2 equals infinity, with capital M equaling 1,000.
Okay, just a minute. Let me get-
Yeah. Sorry, I didn't see where you're at.
It always takes me a moment to type things in. That's
Absolutely.
yeah. Math takes a while to type. Okay, and M
Equals
equals
1.
1,000.
Yeah.
So the M is kind of like the epsilon, but when you're going out to infinity, it's a little different. And my guess is they asked you, what is delta?
Yes.
Okay, so what the epsilon delta changes a bit when you get to infinity. This is something I mentioned at the very end. And instead of saying the absolute value of f of x minus L is less than a number, because L is infinity, so you can't subtract infinity. What you do is you say the absolute value of f of x, I'll even write it as f of x. Okay, and you don't even need absolute value if you're going to infinity, because it's positive anyway, is greater than 1,000. Does that make sense?
Yeah.
Okay, so what we want to do is we want to say, well, we need to find a value delta so that this will always be true as long as you're within delta of negative 2/3. Does that make sense so far?
Yeah, I think so.
Okay, so what we want to do is we want to say, well, let's write this out. So the absolute value of x minus negative 2/3, which is plus 2/3, needs to be less than delta. I don't know what delta is. Delta is a something, and that's our goal, is to find delta. And then we'll always get f of x is greater than 1,000. Got it? So this is, it's the maze. We want f of x to be greater than 1,000, so we're going to work backwards. We're going to start with f of x greater than 1,000 and then find delta that way. Does that help?
Yeah, I'm starting to see the backwards plan.
Yeah, and that's kind of classic. So the absolute value of x, of f of x is 1 over 3x plus 2. Needs to be greater than 1,000. Is that clear?
Yeah, you're starting to get below the screen there though, just a half, yeah.
That's an easy fix.
Yeah.
Okay, well, then you can take a reciprocal of both sides. Is that clear?
Oh, okay, yeah. Mhm.
And then you got to remember, it's a little technical math piece, but very important, is that when you take a reciprocal of both sides of an inequality, the inequality switches. Right? Just like, 5 is greater than 2, a fifth is smaller than a half, right?
Yep.
So in particular, what we can say is the absolute value of 3x plus 3 3x plus 2, sorry, that was a typo. Needs to be less than 1 over 1,000. Is that clear?
Yep.
Okay, now we can divide both sides by 3. Because we need that, we need an x plus 2/3, right? So what we can say is that the absolute value of x plus 2/3, I lost my equation. X plus 2/3 needs to be less than, we're dividing by 3, 1 over 3,000. Any questions on that?
No, I think I got it.
Okay, so guess what? There's our delta. What's delta?
1 divided by 3,000.
Yep. And that's your
That
answer.
one.
It's always easier to watch me do it, isn't it?
By far.
Yeah, that's how it kind of works.
So
Okay, question?
in this case, is L infinity?
Yeah, but see, the special case if L is infinity, that's where you have f of x is greater than whatever your m is.
Okay, so that's what makes it work like on a graph. I was having trouble like imagining how L could be infinity on a graph.
L infinity on a graph means you have an asymptote.
Yeah, so it's okay. That makes sense actually. Thank you.
Right? And the definition of infinity is bigger than every number. Does that make sense?
Mm-hmm.
So what they're saying is it's bigger than every number, so let's try 1,000. See what you need to do to make it bigger than 1,000. And the idea is you can always get it bigger than any number you think of. Do you see that?
Oh, okay. So that's
Yeah.
what M is then? M is like a number to make it bigger than?
Yeah, m is a big number you can kind of think of near infinity. I know 1,000 isn't that close to infinity, but you get the idea, right?
Mm-hmm.
You could try 1,000,000, 1,000,000,000. You know what I mean? The point is that no matter what number you can imagine, you can always get bigger. And you're always going to stay bigger as long as you get closer than that to 2/3 or negative. Sorry. Any other questions on that? Okay, let me get to the big, huge definition. Actually, before that, I want to talk about what's going on Monday.
Actually, I had
Okay.
a question about a different question on the quiz.
Okay.
Or,
Yeah,
I
and
mean, on
I
the,
still have a
on the
question on
home.
my number 9.
All right. I think I'm going to delay it to office hours. The problem is if I answer all the questions, then we won't talk about the derivative, which is the whole point of today. So can you wait till office hours for that? Which
Sure.
is in an hour, basically. because I do want to get to the material today. Otherwise, you're not going to learn about it. And then I will answer. I can't answer all questions because if all questions go 2 hours, then it won't work. But at least I can get a little bit. Unless you have a really quickie. Okay, if not, then wait till office hours and then I'll help you in office hours. Okay, so let me go back about Monday. So I want to give you a heads up. I will not be online Monday. So Monday is, it's not quite an off day. Having a sub doesn't make any sense. I mean, when you're online, the whole thing is different. Normally I'd have a sub teach, but the sub that I have to teach is called YouTube. And believe it or not, I spent, I think, 4 hours on this 30-minute video I made, and it's not done yet. It'll be done, and I think I have another hour left. So there's going to be a YouTube video, and these are always posted on that YouTube channel I've got anyway, and it's the same channel. I can't give you the link yet because it doesn't exist yet, because I'm about an hour away from being done. I have it recorded. What I haven't done is I haven't watched it and made sure it looks all good. Will it be a quiz Monday? Yes. So the quiz on Monday is the same time. So the only difference is I'm not going to be here. Okay. All right. So there's still going to be a quiz, but I won't be here. So you can take the quiz at the same time, which is 8:35, and that goes 20 minutes. But the good news or bad news, however you want, is you can watch the lecture whenever you want. The lecture is, I think it's 29 minutes and 35 seconds or something like that. It took me 4 hours to make this sucker. You know how I'm giving a regular lecture is so much easier than to try and make a polished one on YouTube. But I think it's getting pretty good. Okay, so just let you know. So that's going to happen. I will not be in office hours on Monday, but I will be around on the weekend to help you out until Sunday evening, and then I'm off, and I'll be back Monday night. Just let you know that. So that's pretty much, it might be the only time. There may be one other time this quarter where I'm going to have to do that. And that would be the totally different reasons. The other one is I might give a national lecture. So I know you're important, but this is a big national lecture on some of the stuff I've been doing online. So just let you know, but I don't know yet. I don't know when the lecture is going to be yet. And if it's not in the morning on Monday, Wednesday, Friday, then there's no issue. Otherwise, I'll always be here. Even though I'm sick, I could be here because I can't give it to you. And I'm not sick, by the way. Okay, I'm in pain right now, but I'm not sick. Okay, and you'll never guess why I'm in pain. Something evil happened. Yeah, no one's gonna guess. I was outside and a bee stung me. It still hurts. No fun at all. So other than the pain, I can help you. Okay. So let you know Monday I'm gonna be out, and I won't be answering emails or anything like that from Sunday evening till Monday evening. So that's my time to be out. And then I'll be back. I'll be around Sunday morning, and I'll be around Sunday daytime, and then I'll be around Monday night and Tuesday, and from then on. So just let you know that that's my schedule, is I'm taking a little time off. Any questions on that? And again, the lecture will be on my on the YouTube channel that has all lectures, but it's not there yet because it hasn't. I'm still an hour away, I think. Okay, now comes the biggie, and that is the definition of the derivative. Okay, the epsilon delta definition limit was important, but on a scale of 1 to 10 as importance for this class, it's a 2. On a scale of 1 to 10 of importance for the definition of the derivative, it's a 10. Okay, it's the most important of all definitions of this entire course. Not today, every day. So it's very important we get this down. And the nice thing is that on day 1 of this class, We kind of talked about it already, but we didn't have the formality language that we needed to formally define it. And now we do. So let me give you the big definition. And the good news is it's much easier than the epsilon delta definition. So this is the big definition. And by the way, it's big, so I'm going to make it bigger. How about 30-point font? Big old red, bold. I just want to scream and yell it as much as I can because it's that important. Okay, and it says the following. If f of x is a function, then the derivative of f of x at x equal some number, c, is defined by, or is, and there's actually two different ways of notating the derivative. There's two different notations. They're both important and they're both helpful in different situations. So the first way is to write f prime of x. And I'll even f prime of c because we're evaluating it as c. So that's f with a little prime on it, and it's called f prime. And we can read it as the derivative of f of x. The other way of writing the derivative is the following. It's df over dx evaluated at c. Okay, and here's the big definition. It is the limit as h approaches 0 of f of x plus h minus f of x all over h. You need to memorize this and not just like have it so you can recite it, but you're going to have to be able to use it and use it correctly. And we've been kind of playing with pieces of this the whole, the last week and a half or so. Now we've got it. And this is the definition of the entire quarter. So you got to get this down. So I want to talk about it a bit before I do an example and stuff and just see what it says. Okay, so the first thing is we saw the f of x plus h minus f of x over h. When did we see that? And in fact, let me give you the other definition, which is the same thing, but it's slightly adjusted. Instead of h going to 0, we can let x goes to c. And we can, instead of write x plus h, we can just have x. Instead of f of x, you can have c. And then you can have x minus c. Okay, now you may not realize, but those are exactly the same things, even though they look kind of different, don't they? And the reason why these are exactly the same things is if you think about x minus c as being h, then this works. So if x minus c is h, substitute in, you literally get the same thing. Okay, you'll get a negative. It'll look like it's negative, but it's not, because it's approaching left and right. And if you switch where you're approaching, you multiply by -1. So that's not a problem. So I'll let you look at it for yourself, or you can just trust me, these are the same. When have you seen f of x minus f of c over x minus c? Where have you seen that? On day 1, that's a hint.
Average rate of change.
Yeah, secant line, right? That was the slope of the secant line, average rate of change, right? And then after that, we learned about what limits were. So now we can actually formally say the limit as x approaches c of f of x minus f of c over x minus c, which is the same as the limit as h goes to 0 of f of x plus h minus f of x over h. Okay, they're the same. Okay, so that's one thing, is that what this does is it gives the equation, the slope of the tangent line. Because if you take the secant line and then you squish the points into one, take a limit, that's the slope of the tangent line. And that's what we talked about on the first day class. Okay, so now basically what we kind of talked about in the first day class, we now have it formally, because we understand what a limit is. Now I want to mention the reason why there's 2 different ways of writing the derivative. Okay, and my guess is if I asked you to guess, you wouldn't guess. And it's history. Okay, it really is history. So the history of calculus. So who discovered calculus? Anyone know?
Isaac Newton.
Okay, any other ideas? Okay, the idea here, something that it's hard for you to understand, and me too, is that there was no internet. Then there was no phone. In fact, not only that, you could even get from Germany to England. It'd take days and days and days and days just to get there. So there are actually 2 people that discovered calculus at the same time. One was Isaac Newton, and the other was Leibniz. And Newton wrote it this way, f prime of c, and Leibniz wrote it as df dx. So 2 different people did it, and they had different ways of thinking about it, but it was the same thing. And they, they figured it out at the same time, but they couldn't talk to each other, because if you're in England and your friend is in Germany, you're gonna take a boat and then a horse and ride your horse from the edge of France to Germany. It's a long way. Okay, whereas now you just text the person, right? But that didn't happen then. So historically, there were 2 people that invented the calculus, and they had different notations. Okay, any questions on this definition? Okay, so memorize it. Okay, it's your responsibility to have it in your brain. Okay, it's the most important formula of all of calculus. Okay, not just this quarter, of the entire year. This is the biggie. Okay, any questions so far? Okay, it's probably a good idea to maybe do an example. So let's look at an example. Find the derivative of f of x equal, how about x minus x squared? Maybe even 3x minus x squared. At x equal 2. Any questions on the example? On the question? All right, well, the good news is, in a way, you don't have to memorize it because it's sitting there right above that line. But eventually, you need to memorize it. But for now, we can just look at that and say, well, we need to find the derivative. That's f prime, valued at 2. So let's write this out. F prime, evaluated at 2, is equal to, and now it's going to be a limit as h approaches 0. I would say 90% of the time, the first limit up there is easier than the second to deal with. So I recommend trying f of x plus h minus f of x over h instead of f of x minus f of c over x minus c. It's typically easier. Okay, but let's do it. So the limit as h goes to 0, and then we do a fraction. And then we have f of x plus h. Very important to know how to plug in x plus h into 3x minus x squared. Okay, so just note f of x plus h in this case is not 3x minus x squared plus h. Okay, it doesn't mean just put a plus h at the end. What it really means is everywhere I see an x, I replace that x with parentheses x plus h, end parentheses. So let's do that. So we're going to have 3 parentheses x plus h minus, I'm sorry, it's not minus, and then parentheses x plus h, and the parentheses squared. And then we're going to have minus f of x, so minus, now you want to put parentheses 3x minus x squared. Very important to have the parentheses around that second term. All over h. I think I should make it a little bigger. There we go. Any questions? Okay, so now what I'm going to do, and hopefully you're used to this from doing limits, what do we do next in one word?
Plug.
You might be thinking about it. Yeah, simplify. Algebra is another word you can use. So simplify or algebra. I think algebra is a better word because actually what we're going to get is not going to be simpler, at least in the next step. Eventually it's going to be simpler. But the next step is just algebra. So the 3x plus h becomes 3x plus 3h. The x plus h squared becomes an x squared plus 2xh plus h squared, and we're subtracting it. So it's minus x squared minus 2xh, and then minus h squared. The minus 3x minus x squared becomes minus 3x plus x squared. Multiplying the negative through. Oops. Any questions so far? Okay, so now we can do some more simplifying. Now we'll simplify. Okay, if you look at what I just wrote, I don't think that's simpler than what we had before, but it's helpful. Now we can actually simplify. So what goes away?
The 3x and minus 3x.
Yep,
Cancel.
the 3x and minus 3x. Let's kill them. So I can cancel out the 3x with the minus 3x. What else goes away?
X squared.
Yep, we have a minus x squared, and we have a plus x squared. Any questions so far? Okay, we're getting there. All right, what can I do with that numerator? Here's the hint. There's something in common in all the terms.
Take the H out.
Yeah, I can factor the h out, and I can write it as h times parentheses 3 minus 2x minus h. And that's good because now that I have it in multiplicative form instead of additive or subtracting, now what am I allowed to do? So what can I do?
Cancel the H's.
Yep, I can cancel the h's. Algebra, a lot of algebra. And get used to it. Okay, now do you remember, what do you always do after you cancel?
Plug it in.
Yep, plug it in, plugs in beautifully if h is 0. This is just 3 minus 2x. And there's your answer. Any questions at all on this example? Any questions?
Where did the last minus h go in that last step?
The very end. Okay, so notice it says limit as h goes to 0. So what I do is I say, well, what happens to this fraction when h gets close to 0? Well, the minus h becomes minus 0 and it goes away. Does that make sense?
Yes.
Yeah, so that's the plug it in. Okay, but you can't plug in on the step before because you get 0 over 0. And I want to mention something, and this is important actually. What I told you when we first did limits is the first step was to plug in. Do you remember that? And cross your fingers and hope you don't get 0 over 0. I didn't do that. How come? I didn't bother doing it. Anyone know? Okay, if you don't, let's go to the definition. And if you go to the definition, whatever the function is, this is general. If you plug in h equals 0, you get f of x minus f of x, which is 0 over 0, and you get 0 over 0. So whenever you are finding the derivative using the definition, we need to we don't even need to bother plugging in. All right, the very last thing I want to do is I want to say x equals 2. So that's easy. So now, so what I really was, and I guess I was cheating, that was f prime of x. And now I want to find f prime of 2, and the idea is we've already done all the work. So what is f prime of 2? And the idea is easy. You should be all do it in your head.
-1.
-1. I'm going to show the work in case someone's not following. 3 minus 2 times 2, which is equal to -1. Okay, so the idea here is that the derivative of a function is a function because we're allowed to plug in a value into the derivative. Does that make sense? Any questions on this example? Any questions at all?
Once you plug in the 0 for the h, so like at the end when you do f prime of 2 is -1, you don't write limit as h approaches 0 anymore?
The limit was to arrive at the answer. So that was using the definition to find out what the answer was. So all this limit stuff is all the middle steps. Do you see that?
Yes.
-1 is the punchline. Does that answer your question?
Yes, it does. Thank you.
Yeah. But if you didn't have this limit definition, good luck, just knowing it's -1, right? That's hard. Okay. I will tell you something though, and it's what you're not allowed to do until after the exam, and that is there's an easier way of doing it. But we can't do that yet because we need to use the limit definition to prove the easier way, and then we're allowed to use the easier way. So I want to let you know, if you, for some reason, have taken some calculus and decided not to finish or something, and you know the easy way, and you use it on the exam, what's going to happen?
You won't get full credit.
Yeah, in fact, you'll get hardly any credit. Okay, because I could do this whole thing in my head in 1 second, and you will be able to maybe in 2 seconds, you guys, because you haven't been in calculus as long, but you'll be able to do that also in just a few seconds. But we're not there yet, and we don't have those tools, and you're not allowed to use the tools until we have the tools. Got it?
So just to clarify, 3 minus 2x is the derivative, and then -1 is the solution to the derivative?
Okay, so the derivative is a function. And a function means that if someone gives you a number, the function gives you a new number. You know what a function is? Right? So the derivative as a function is 3 minus 2x. The derivative at x equals 2 is -1. Because the function 3 minus 2x at x equals 2 is -1. Does that help?
Yes.
Yeah, it's kind of abstract, but that it is important to get that down. Okay, other questions? It's very important to ask questions now because this is the big concept for the entire course, not just for the day, but for the entire course of calculus. If you don't learn this and you don't understand derivatives, you will fail this class. So you need to get this down. So 3 minus 2x is the derivative of f of x. -1 is the derivative of f of x evaluated at 2. Does that help? Okay, so that's kind of the way you gotta use those words. Okay, we'll do another example or two, but I want to do a graphical example first, because we want to talk about tangent lines. Okay, so we actually did this already, but we did it on day 1 before we had a really full understanding. But now we get to it again. And I like Desmos. Desmos is pretty good. I can show things nicely for you guys. I don't know if you like Desmos, but if you don't, then it doesn't matter. You still got to look at it. There's other programs that do this too. Okay, so I'll give you an example. This is x cubed minus x squared minus 2x. That's a function, right? Okay. By the way, could you find this derivative using the limit definition? Could you find the derivative of x cubed minus x squared minus 2x? Do you think you could do that? Yeah. Do you think you'd want to do it?
It'll get messy, but you can do it.
Yeah, if you've no fun at all, because there's an x cubed, so you're gonna have an x plus h cubed. And do you guys remember how to cube out polynomials? Very messy. Do you remember that? So this can be done.
You cube square root it, wouldn't you?
What's
If you
that?
had if you had x cubed, wouldn't you square root it with a cube?
No,
with
no,
the
you
three?
can't do that.
Oh.
No, you'd have to go x plus h quantity cubed. So then if you don't have it memorized, you have to do x plus h times x plus h times x plus h. You FOIL the first, and then you multiply the thing out and be very long. Does that make sense? So we don't want to do it that way. I want to show you how to do something visually. All right, so what I want to do is I want to say, well, let's look at x equals 2. Any questions so far? So what I want to do is I want to look at it graphically to see what is the derivative at x equal 2. Now we did this on the first day of class, didn't we? We just didn't call it the derivative, did we? What did we call it? What did we do on the first day of class?
The tangent line?
Yeah. So the derivative is the slope of the tangent line. We saw that in the formula, remember? So now if you don't know the slope, that's okay for now. Okay, because I don't want to go through the whole messy thing. But what I do know is it goes through the point 2, 0. Is that clear? And remember, y minus y1 equals mx minus x1. So y1 is 0, so it's just y equals m times x minus 2. And what I'm doing here is I can write down the y equals m times x minus 2. Okay, by the way, what Desmos gave me is that the tangent line in blue. No, why is it not the tangent line? Because it goes through the point. 2 points, but what should the tangent line look like?
It doesn't have the same slope.
Yeah, it shouldn't cross. It's not supposed to cross. What's it supposed to do at that point? Right? It's not supposed to cross the curve. It's supposed to touch. Yeah, it's supposed to touch the curve, rest on the curve, just at the one point. So what I can do now, this is why I like Desmos, I can take the slider and I can move it. Do you think I'm moving in the right direction right now? No, I want to move it this way. I want to make it so that it just rests nicely. On the side, it just rests nicely on this graph. Like that. Okay, I could even zoom in to see what it looks like. And the idea is the line should look just like the curve if I zoom in a whole lot. Does it? Looks good, doesn't it? Okay, I could even move it a little more. And again, it's hard to get perfect. But if you want to round, maybe we'll round to 6 and see if that works. Okay, now if I zoom out again, does that look like it's tangent to the curve at the point? Okay, it looks pretty good, doesn't it? So again, this is an eyeball. Again, this isn't using the full formal definition. This is using it with the eyeball. And that says that the derivative of x cubed minus x squared minus 2x evaluated at x equals 2 is approximately 6 from what we can look at. Okay, we'll find out later, not today because I don't want to go through a whole cubic, it's kind of long, that actually it is exactly 6. Any questions on the picture? Any questions? Okay, so I know in the first section there were some questions on how to do this. This is how I recommend doing it, is you draw it in Desmos, you write it as an equation with a slider where m is unknown, so keep it as m, okay, or whatever letter you want to use. And don't forget, y minus y1 equals m, x minus x1. That's a very important formula. And that'll give it to you. Okay, any questions on that picture? Okay, let me go back to our example, but I'm going to do a kind of a part B on our example. And now it's easy as a hint. Then part B will be. Now find the equation of the tangent line. at x equals 2. And the good news is this is easy. We've done all the work. To find the equation of the line, what two things do you need? If you want to find the equation of the line, back to beginning algebra. What two things do you need to find the equation of a line? A slope, okay, a slope and an intercept, but it doesn't have to be an intercept.
In a point.
Yeah, slope and a point on the line. That's all you need. You could do intercept, but we don't have an intercept, but we do have a point. So note the slope was equal to -1. And the point has x coordinate 2. How do you get the y coordinate?
You plug in 2 into the equation.
Yep, that's it. We plug in 2 into f of x. And we get 3 times 2 is 6. Minus 2 squared, 6 minus 4, which is 2 in this case. Okay. And now, again, you are responsible for remembering your beginning algebra. The equation of a line is going to be y minus y1 equals mx minus x1. So I'm going to write y minus y1 is just 2 equals m is -1 times x minus x1, which is kind of coincidentally happens to be 2. It won't always be 2, the same number. And then typically you simplify it a bit. And we can rewrite this as y equals -x. And then we're going to have a +4. Any questions on that? How do you check your work? What's a nice way of checking your work on the computer? That's a hint.
Graph it on Desmos.
Yeah, except I'm gonna correct the grammar. Graph them on Desmos. So let's graph both f of x and the line y equals -x plus 4. Does that make sense? We want to graph them on Desmos. So f of x again was 3x minus x squared. So 3x minus x squared. And then our equation of the tangent line that we got was -x plus 4. And let's zoom a bit. And does that look about right if we're at the point 2, 2? Does that line look like a tangent line to this graph? Okay, so a question was asked, is it okay to leave it in point slope form? Yeah, I'll give you credit if you leave in point slope form, but with Desmos, it's easier to write it this way. So I wanted to put it in Desmos just so I can show you what it looks like. And it looks good, doesn't it? That looks like the tangent line. Okay, it goes through the right point. It doesn't like cross. It just touches it perfectly. Any questions at all on this example? Any questions? Okay, so let me go back and talk about again what we're doing. So the next thing I want to talk about is why this was all done. let me ask you again, this history. You've all heard of Newton. You may or may not have heard of Leibniz, but I'm going to go to Newton. Why did Newton discover calculus? Anyone know the history? What was he trying to do? Going to open this up. Little history lesson.
Is it because of the apple falling?
Because of what?
Gravity, the apple falling.
Yeah, that's what you hear Newton sitting by a tree and an apple hits his head and he's like, but that's actually not true. That's not the reason why. And whether an apple really hit his head when he was near the tree, I don't know. That's not why Newton that's not why Newton did this actually.
Is it to discover something about like the relationship between the earth and the sun?
Yeah. Okay. And you get the right idea at least, but not the earth actually. All what he called in those days heavenly bodies. So the earth, Mars, the moon and the earth, not just the earth and the sun, but the moon and the earth. Halley's Comet, or what was that one, the X something, what was that comet that just came last month? But comets, anything that orbits. And Kepler came up with Kepler's law, which was that things always orbit in what shape?
Ellipse.
Yeah, they always orbit in an ellipse. What Kepler did not do was explain why. What he did is he literally had a really good telescope and he was just really careful every single night. And he plotted the points throughout years and he realized it was a perfect ellipse. It just looked perfect. But Kepler did not prove that it was an ellipse. Kepler drew a graph and everyone looked at it and said, well, that looks like an ellipse. Newton said, you know, what's going on is the sun is pulling on this planet with gravity. And because of that, the ellipse happens and was able to actually prove it. And Newton proved Kepler's laws. So that's a little history. You know, it's important history because that's where that's the reason why calculus happened. Now, remember that in those days, almost like being in Tahoe, there was no light pollution because they didn't have a light bulb yet. So, and there was nothing else to do at night either. So everyone just sat up, like checking out the stars all night. And so they were thinking about it all the time. And they were also using it for navigation purposes. I think Leibniz did it for the same reason, but he's not the one that proved Kepler's laws. He just did calculus. I don't know all the details, but that's kind of the history. And he happened to do it at the same time. Newton was more famous because he had a big official status in England, whereas Leibniz didn't have an official status. He was just some nerd, kind of like me. Okay. Whereas Newton had the official status, so everyone listened to him. So just let you know, that's the history of calculus, kind of the brief history of calculus. So the idea here, and now let's go back to the picture of Newton sitting under the tree and an apple falling on his head. And, you know, eureka moment, right? Okay, I doubt that really happened, but we can say it. And what he basically figured out is that the acceleration is a constant. Okay, the acceleration on Earth is constant as long as you stay on Earth. And this is the hard thing about Zoom. I can kind of do a little bit. Here's this pen. Maybe you can all try it too. Take your pen or anything that's not too big, put in your hand and throw it in the air. Can you all see it? What shape was its path in?
Parabola.
Yeah, okay. And that's not very hard to calculate, okay? You can take a video and you can plot points if you want, or you can just visualize it and see that you get a parabola. that make sense? So the shape is a parabola. So let me just write a general parabola. So in general, a parabola is y equals ax squared, hopefully you all know this, plus bx plus c. Okay, now what Newton did is he, calculated it, as in he plotted a bunch of points, which you can do, and found out that y was always equal to negative 9.8 x squared. Sorry, negative, not 9.8, 4.9 x squared plus, I'm going to just say Vx plus C. I lost a plus. And I'll even write, well, we'll write it that, where V and C are constants. Any questions so far? Okay, so we could do a few things. One is we can say, well, how fast is it moving? So how do you find out how fast this guy is moving? Take a derivative, okay? Because the derivative is the velocity. Got it? So the derivative is the velocity, okay? And that's really important. Or let's try it the other way. The velocity is the derivative. Okay, sometimes you'll say the rate of change is another way of saying the same thing. And that is in physics. Okay, any questions on that? Any questions? Okay, so the velocity is the derivative. So we need to find the derivative. So we need to find what is the derivative. Find y prime. So here's what I'm going to do. I'm going to find y prime just in the first term. And I'm going to be in good shape after that. So let's find y prime for the first term. So to find it for the first term, well, that is going to be, take a look. We have already done, well, we've done this one. So we're going to do basically the same idea. It's going to be almost exactly the same. But I figure it's important enough. We're going to take a limit as h approaches 0 of, and I'm just going to do the negative 4.9 x squared. Okay, but I could just do the x squared if I want. So, and I'll show you why. So I'm just going to do the x squared. And to do the x squared, all I have to do is I can go fraction x plus h. Oops. X plus h squared minus x squared all over h equals. And then I FOIL.
It's going off the screen a little bit there at the bottom.
Okay, thanks for letting me know.
Thanks.
It's back on now. Yeah, sorry about that. What I see is not what you see, so you got to let me know if you can't see it. Because for some reason, I get to see lower. Okay, so this is equal. And now what I'm going to do is I'm going to FOIL. X plus h squared is x squared plus 2xh plus h squared. And then I can say, well, I have an x squared minus x squared. I can cancel those. And then I can factor out the h. And the 2xh becomes 2x, the h squared becomes h. Then I can cancel. And still limit as h goes to 0. And I get a 2x plus h. And now what? Once I cancel, what do I do?
Plug in.
Plug in, and I get 2x. Okay, now let me show you something really nice. We got a theorem about limits. You could always do algebra on the limits. So the negative 4.9 goes outside. So now what we can say is that y prime equals negative 4.9 times 2x plus, what's the derivative of Vx if V is a constant? Yeah, V, because y equals Vx is a line. Derivative is the slope of the tangent line. Well, the slope of the tangent line is the slope of the line, and that's just V. What's the derivative of a constant?
1.
Good guess, but it's 0. There we go. Yeah, Rivers got it, because y equals a constant is horizontal. Horizontal line has 0 slope. So there's my y prime. And just to make it a little prettier, that's equal to negative 9.8 x plus v. And maybe I'll do it the way most people do, is that v really should be a v sub 0, but I didn't want to make it uglier than it was until now. Because that's how people talk. And that's more standard. So I've now found the velocity function. I lost my negative sign. Of anything that's thrown in the air. Okay. And by the way, we're ignoring air resistance. We're just saying gravity is the only thing that affects it. And there's the velocity. So for example, the initial velocity will be v naught. The velocity after 1 second will be v naught minus 9.8. And we now understand velocity. Any questions on finding the velocity or the rate of change? Okay, let me do one more just for fun, since we've got about 5 minutes. I like to go about 10, 15. And that is find y prime, and I'll keep it general. If y equals the square root of x. Okay, what do we have to do? Remember? We use a limit definition. Okay, that's what today's kind of all about. Limit as h goes to 0, which you need to memorize, of fraction. And we're going to have the square root, and where we see an x, we put an x plus h. Minus the square root of x all over h. Anyone lost on what I just did? What do we do now? We've seen something similar to this before. Yeah, we multiply the numerator and the denominator by the conjugate, by the square root of x plus h plus the square root of x. So now I can copy and paste. Hopefully I didn't copy too much. I did. I wonder if this will work. No, it doesn't. All right, one more time. At least I can do that part. Plus the square root of x. And then we got to divide by the same thing. Plus the square root of x. Okay, so let's work this out. All right, so the whole point of multiplying by the square root of x plus h plus the square root of x was the numerator. The numerator becomes very nice. What does the numerator become?
X plus h minus x.
Exactly, x plus h minus x. It's the first squared minus the second squared. Well, the square root cancels the square, and you get x plus h minus x, which becomes even nicer. I hope you can all do this easily. What's x plus h minus x? H. And what's h over h?
1.
1. That goes away completely. Once we cancel, what do? What do you always do after you cancel? Plug in. So we're going to plug in h equals 0. And you just get 1 over 2 root h. That's 2 root x, sorry about that. So it's 1 over 2 root x. And there's the derivative of the square root of x is 1 over 2 root x. So it does take work to get these derivatives. Okay, there's a lot of messiness. But at the very end, it's pretty clean. In fact, you can even write this, if you want, as 1/2 x to the negative 1/2 is the same thing. Wouldn't it be 1 over x? So if h is 0, then you get root x plus root x on the bottom. Now root x times root x is x, but root x plus root x is not x. Root x plus root x is just 2 root x. Does that make total sense? Okay, I look at the clock, it's 10:15. What I want to do now is stop the recording So thanks for coming. And